Consider the complex numbers w and z, where w is equal to root 3 minus I over 2, mod z equals r, and arg z equals theta. Determine in terms of r and theta where necessary the modulus and argument of, first of all, w to the 4. So the r and theta are not going to be important in this one, but let's have a look at this one. So if we look at w, it is going to be down here, and this would be root 3 on 2, and this would be a half, meaning using Pythagoras' theorem that this length is 1, and then a bit of trigonometry, we should see that that one is pi by 6. So that means that w is equal to cis negative pi by 6. So w to the 4 would be cis negative 4 pi by 6, which is cis negative 2 pi by 3. We then want w to the 4 z. So w to the 4 z would be r cis theta multiplied by cis negative 2 pi by 3. So that is going to be r cis theta take away 2 pi by 3. And then z divided by w to the 4, and that would be r cis theta divided by cis negative 2 pi by 3, and that will be r cis theta plus 2 pi by 3. Explain why the points representing z, w to the 4z, and z over w to the 4 in an Argand diagram represent the vertices of an equilateral triangle. Well, there's not a lot of space there, but a diagram is actually a good way to go with this. And I might even draw this on a back page and refer to it. So let's say that this one here is the z. Okay, so this is z, and therefore this is theta. Well, we know that we have theta add 2 pi by 3. I should note that that's r and that's r. And so this is 2 pi by 3 here. And then you've got the theta take away 2 pi by 3 down there as well. So that's r. And that is 2 pi by 3, meaning that this is also 2 pi by 3. So if we now draw the triangle like this, each of the little angles in here, because of the 2 pi by 3 in the middle of those triangles, each of those is going to be pi by 6. So every single one of those is pi by 6. And therefore, the angle at each vertex of the triangle is pi by 3. So we have an equilateral triangle. So the diagram is good. You could try a written description of that. You could say something like all points are equidistant from the origin and all pairs of points subtend angles of 2 pi by 3 at the origin, which is shown in the diagram here. In an Argand diagram, the vertices of an equilateral triangle lie in a circle with center at the origin. One of the vertices represents the complex number -8 plus 2i. So I think what they're doing here is giving us our z. Determine in exact Cartesian form the complex numbers represented by the other two vertices. Well, let's go back and think about this w to the 4, which is this one here. So that w to the 4 is down there, such that this angle here is pi by 3, because we know that one is 2 pi by 3. And So what we would have is that this is root 3 on 2, and this one is a half. And so we can say the w to the 4 is negative a half take root 3 on 2i. So w to the 4z here is going to be, so w to the 4z is going to be negative a half take away root 3 on 2i, and multiply that by the negative 8 plus 2i, and without doing all of the algebra here, it's going to be 4 plus root 3 plus 4 root 3 take away 1i, and then you want to do the z divided by w to the 4, which is negative 8 plus 2i, and you can divide that by the negative half take root 3 on 2i. And again, I'm going to skip all the algebra. There's quite a bit of fiddling around to get this, especially for 3 marks. And you get 4 minus root 3, take away 4 root 3 plus 1i. Of course, don't forget you don't have to do all of this manually. It is calculator assumed, and so you can put it in complex mode and do it that way.